Hi Year 11. Okay, today we're going to look at the trapezoidal rule. Now last lesson we were looking at finding the area of irregular shapes. Now with the ones that we did last lesson, they all had straight sides. This time the trapezoidal rule is used to help us when we have one side that is not straight, so it's got a curvy side. Okay, the trapezoidal rule, unsurprisingly, comes from the area of a trapezium, which you can see in front of you right now. So the trapezoidal rule is basically the same formula. Just notice that instead of having an A and a B, we have a D with a little f and then a D with a little L. The F stands for the first line and the L stands for the last line. Okay, let's have a look at the example and we'll go through it from there. Okay, you can see here, so it's used once again for land, lakes, that type of thing. We've got here, a lake forms a boundary for a block of land. So the lake is the curvy line. We can't get an exact answer, so this will be an approximate answer. Answer to the nearest square metre. So we have in this example here, the 22 and 20. Basically, if we look at it side on, this here would be our DF for our first line. And the 22 will be the DL for the last line. The 36 will be the height. So from that, we will simply go A equals, okay, the height is 36, put it over 2. Then we will go substituting in 20 plus 22 equals 756 metres squared. So that would be an approximation for that example. Okay, let's turn over and have a look at the next question. Okay, so the trapezoidal rule you can see here. It will give us the area of the shape. We have a DF, which is the first line, and a DL, which is the last line. The H is the distance between the parallel sides. Now, because this is an approximation, if we were to apply the trapezoidal rule more than one time, we would get a better estimate for the area of the figure. So in this next example, we're being asked to do 2 applications to estimate the area of that irregular figure in the diagram. Okay, so this is how we'll do it. You can see here we have section 1 and we have section 2. So taking section 1. Okay, section 1 we have, notice here that this will be our height. Okay, that's going to be our height. Now what we're doing is we're dividing the entire figure into strips. Each strip must be the same width. Okay, so you can see here the whole thing was 36, so this has to be the same, which means that the height will be equal to 18 in both the parts of the question. Okay, we now look at our parallel lines. This here is the first line, so that'll be our DF. This line in the middle here will be our DL on the first application. So what we're basically doing is we're going to find the area of section 1. So section 1, we will have a height of 18, we will have a DF of 22, and then we'll have a DL of 60. Okay, if we move on to section 2. All right, moving on to section 2. So now we're doing this side of the area. Okay, the height has to be the same again, so the height is 18. Now, what we've got here is we're doing the second section. This line here is now the first distance on our trapezium. So this becomes the DF line for the second application. And then this will be our DL. So notice this line in the middle is used for both parts of the question. It's a DL in section 1 and it's a DF in section 2. So going back over here, we now have the DF will be 60 and the DL will be 48. Okay, so once we have all those numbers together, we can put it into the formula. So our area is going to be, now we can do it in one step, so we can simply write 18 over 2. Now, first application, we're using these figures here. Now we go on to the second application. Obviously, we're going to add them together to get the whole area. We have 60 plus 48. So that will give us the whole area of the figure, which will give us 1710 centimetres squared. So that is when you do it in 2 applications. Okay, now you're going to be moving on and completing the exercise that is attached.